Okay, so an arc length is calculated by taking, again, basically the measure of the central angle that corresponds to an arc measure that's cut off on a circle, okay, and then relating that to its radius. Okay, so there's a couple different ways to measure arc length, depending on whether your angle measures are given in terms of radians or in terms of degrees. So in the past, in geometry last year, you guys were exposed only to degrees. So your arc length, which is designated as a lowercase s, was equal to m over 360 times the circumference. It's some portion, some fraction of the whole circle's circumference. The fraction is whatever this arc measure is, and the arc measure corresponds directly to the central angle measure, the angle at this center when the radii are connected. Okay, and so because circumference can be calculated in a number of different ways, it can be calculated as d pi. It can also be calculated as 2 pi r, right? So these are the three different calculation methods you have for arc length if your measures are in terms of degrees. Okay, so you can use whichever of these you need. Most likely it would be this last one because they'll give you a radius measurement, and then m is your angle measure. Okay, so m is that central angle measure right here. Okay, now if instead of being calculated in terms of degrees, if your arc measure is calculated in terms of radians, okay, so it'll often be designated as theta for this. So here is theta. And then your calculation is based on taking this form right here. If you know that theta in terms of radians can be converted by taking your angle measure and converting out of, again, degrees. What was the conversion between degrees and radians in angle measures? 180 degrees is equivalent to pi radians, right? So if we want to, if we took this calculation right here, 2 goes into 360, 180 times, so really you're kind of looking at m over 180 times pi r. Well, what we see right here is pi radians can replace m times pi over 180. So if we took m times pi over 180, this portion right here, and we replaced it with theta, we'd get our arc measure in terms of radians, and that is simply this measure right here, theta times r. So it winds up being a really easy calculation. Okay, so this is measured in radians. And here, theta is your central angle. Okay, so you can choose either one of these or any of these forms depending on what they give you in the problem. And so if they ask you to find arc length given r equals 9 and the angle measure is 50 degrees, which of these should you use? The degrees or the radians? Degrees. They give you degrees, right? So if you just take arc length is equal to m over 360 times 2 pi r and substitute in the pieces that they provide. So our m value is 50 over 360 times 2 pi. Our r value was 9. And so if we just start kind of canceling what cancels here. So the factors of 10 cancel. The 2 goes into 36 18 times, 9 goes into 18 twice. So you wind up with 5 pi over 2. And so that would be your arc length. Now, if instead they give you r is equal to, let's say, 10, and theta is equal to 2 pi over 3, and now they gave you your angle measure in terms of radians, so you should use this calculation, and the arc length is going to be theta r. And so it's just a matter of plugging that in. So 2 pi over 3 times the r value, or sorry, yeah, r. And so you get your answer, 20 pi over 3 would be your arc length, okay, for this second example, in which they gave you the angle measure in radians.